Power Platform lets you build apps fast, but without the right controls, data can leak just as fast. In this video, I'll show you how to secure Power Platform using a layered approach, covering identity, data, movement, and execution. So whether you're a maker, admin, architect, or a security professional, this will give you a clear and practical starting point. Before we look at security controls, it's important to understand what we're actually trying to protect. In Power Platform, this typically comes down to two key areas. First, your data. This includes protecting it from loss or exposure, as well as preventing unauthorized changes or corruption. Second is service reliability, making sure your applications, automations, services remain available and reliable without disruption. Because when either of these are impacted, it leads to real business consequences. This can include financial loss, damage to reputation and trust, and even regulatory or legal issues. So ultimately, security isn't just a technical concern, it's about protecting the business. So how do we protect all of this? It's about getting the balance right. On one side, we want innovation, enabling makers, teams, and business to move quickly and build solutions. But on the other side, we have risk around data exposure, misuse, and unintended consequences. So if we focus too much on innovation without controls, we increase risk. But if we lock everything down, we slow down the business and limit value. So the goal isn't to block innovation, it's to enable it safely. And that's where a layered security approach comes in. The best solutions are not the most locked down, they're the most well controlled. To design effective security, we also need to understand the risks. And this starts with two simple questions. Who is involved and why? From a who perspective, risk can come from different actors. This includes users, insiders within the organization, external actors, and increasingly AI agents acting on behalf of users. But just as important is the why. Not all risks are malicious. In many cases, issues are unintentional. For example, misconfigured flows, oversharing data, or incorrect permissions. Of course, there are also malicious scenarios where someone is deliberately trying to exploit the platform. And the key point here is that both need to be addressed, because in Power Platform, many of the biggest risks actually come from well-intentioned users or automated solutions behaving in unexpected ways. And with AI agents, this becomes even more important because actions can be triggered dynamically at scale. So how do we manage these risks while still enabling innovation? The answer is a layered approach to security. Instead of relying on a single control, we apply layers, each addressing a different aspect of the risks. Starting at the top, we have identity, controlling who can access the platform. Then environments and network, defining boundaries, isolation, and access context. Next is data security, controlling who can access data and at what level. Then data movement, controlling where data can flow between systems. Then application and automation, controlling how actions are executed. And finally, monitoring and compliance, which spans across all layers, providing visibility and control across the platform. Together, these layers create defense in depth, ensuring that even if one control fails, others are still in place. Let's start with identity, which is all about who can access the platform. In Power Platform, identity is handled through Microsoft Entra ID. Every user, application, and service accessing the platform is authenticated through it. This is where your first line of defense sits through controls like authentication and MFA. Without these, if the account is compromised, an attacker can access the platform using completely legitimate credentials. On top of that, conditional access adds context, allowing you to restrict access based on things like device compliance, location, or risk level. So it's not just who the user is, but how and from where they're accessing the platform. Once inside, access is controlled through roles. At a platform level, you have roles that define what users can do within the environments, for example, who can create apps or administer environments. And as you go deeper, access is further controlled at the data level through Dataverse roles, which define what users can see and interact with. It's also important to remember that identity isn't just about users. Applications, flows, and agents also run using identities, often through service connections or service principals. If these identities are over-permissioned or not properly managed, they can perform actions at scale, often without visibility. So identity isn't just about logging in, it's about controlling access at every level of the platform for both users and non-human actors. Next is the environment and network layer, which defines where your solutions run and how they're isolated. In Power Platform, everything runs inside environments. These act as boundaries, separating development, testing, and production workloads. This isolation is critical because it prevents changes, experiments, or issues in one environment affecting others. Access within each environment is controlled through roles. For example, who can build apps or administer the environment? You also have environment level settings, which control things like sharing, behavior, and feature availability. Managed environments add additional controls such as limits and visibility, helping you manage usage at scale. And environment groups allow you to apply consistent controls across multiple environments. From a network perspective, you can further restrict how environments are accessed and connected. For example, you can limit access to specific IP ranges or integrate with virtual network to ensure traffic stays within the trusted boundaries. And using subnet delegation, you can place workloads into specific network segments for tighter control. Overall, this layer is about containment, limiting the blast radius if something goes wrong. For example, if environments aren't properly segregated, someone could build or test a custom solution directly against production, increasing the risk of accidental data exposure or disruption. Or without network restrictions, access to your environment could become from unmanaged or untrusted locations. Next is the data security layer, which controls who can access the data and at what level. In Power Platform, this is primarily handled through Dataverse, where your data is stored and secured. Access is controlled through security roles, which define what users can do and are scoped across business units, teams, and individual users. As you go deeper, you can control access at a very granular level, down to individual records or even columns within a table. This hierarchy allows you to precisely control who can see what data, which is critical when working with sensitive data. Because access to a system doesn't mean access to all of its data, beyond access control, the Power Platform also protects the data itself. Data is encrypted at rest, and you can use custom managed encrypts for additional control. You also have audit logs, which track activity and changes, helping with visibility and compliance. And also features like Logbox ensure that even when privileged access, such as from support engineers, is controlled and approved. So this layer is all about protecting the data itself, ensuring it's only accessible to the right people and protected even behind the scenes. For example, without a proper role design, a user might be able to access a table and see sensitive information like salary or personal data that they shouldn't. With row and column level security, you can precisely control what each user can see. Next is the data movement layer, which controls how data flows between systems and where it can go. In Power Platform, data movement happens through connectors, which allow apps, flows, and increasingly agents to interact with different services. This is where one of the biggest risks exists, because data can easily move from trusted systems to untrusted ones. To control this, you can define which connectors are allowed or blocked within your environment. You can also control what actions those connectors can perform. For example, whether they can send data, read data, or write data. Advanced connector policies give you more granular control over how connectors behave as well. You can also restrict where data is allowed to go by limiting connections to approved endpoints only. At a broader level, tenant isolation allows you to prevent data from being shared across organizational boundaries. This layer becomes even more important with agents because they can dynamically retrieve and send data based on prompts and context, often across multiple systems. Without proper controls, this can lead to unintended data exposure at scale. So this layer is all about controlling how data flows and ensuring it stays within the trusted boundaries. Next is the application and automation layer, which is about how actions are executed. This includes apps, flows, and agents, all of which perform actions, not just display data. The key concept here is execution context, meaning what identity something runs under. For example, a flow might be triggered by a user, but run using a connection with different permissions. This means the outcome depends not just on the user, but on how the solution is configured to run. You also have different types of execution logic, apps driven by user interaction, flows that automate processes, and agents that can dynamically decide what actions to take. This is where the risk can scale quickly because a single flow or agent can perform actions across large volumes of data or multiple systems. That's why controls like connection ownership, trigger conditions, and approval steps are important. So this layer is all about controlling how actions are executed and ensuring they run safely and predictably. Finally, we have monitoring and compliance, which provides visibility and control across all layers. Unlike the other layers, this capability spans the entire platform, from identity through to execution. For visibility, you can use the Power Platform Admin Center for operational insights, Dataverse auditing for data activity, and flow run history to understand how automation is executing. For agents, you also have analytics through Copilot Studio and Copilot Hub, giving insights into interactions and behavior. For detection, you can use alerts and analytics within the platform, as well as signals from Microsoft Purview and Defender for Cloud. Apps to identify unusual or risky activity. And when something does happen, you can investigate using audit logs in Microsoft Purview and take action through the Admin Center, such as disabling flows, revoking connections, or enforcing policies. So this capability ties everything together, ensuring that you not only control access and behavior, but also have full visibility and ability to detect and respond when needed. Even with strong controls in place, monitoring is what gives you confidence that those controls are working as expected.